everybody, so today's subject is organic chemistry. Those are all skeletal structures, which only carbon atoms are being presented. All the lines you see here, they are bonds. For alkanes, they're not reactive in their gas form when they're shorter, but they're solid form when they're longer in room temperature. The alkanes are actually saturated because it has the maximum amount of hydrogen atoms around them. And this is the most simple one, only bonds, single bonds between them. Alkenes. So when you see double bond, it's alkenes. Very simple. When you see triple bond, it's alkynes. And the properties of alkenes and alkynes is basically they are all unsaturated because they have less amount of hydrogen atoms, and they're tight bond because you see it's double, it's triple. So both of them, they're not soluble in water, and they have low melting point. Okay, so below here it is cycloalkane. When you see something that is in cyclic shape, then it will be cycloalkane. It is insoluble in water, and if it has branches like halogens like bromo and chloro, then it will be susceptible to chem attack. Those are structural isomers. So basically, structural isomers are the isomers that has the same molecular formula, but they are arranged in different ways. 5 carbon atoms, this one has 5, but they are arranged in different ways, so they have different properties. For example, like pentane can be used as film. And this one, it is cis-trans isomers. So basically, trans means on different side, and cis means on the same side. And this only applies to non-H group. So this methyl and this ethyl, different side, trans. This methyl, this ethyl, the same side, cis. For cis, it has higher boiling point, and for trans, it has higher melting point. For alkanes, you just see what's the prefix in the name. So if it's hexane, so it means 6 carbons, 1, 2, 3, 4, 5, 6, and then you use lines which represent single bonds to connect them together, and that's the skeletal structure. When you draw alkenes and alkynes, you need to make sure that double bonds and triple bonds are horizontal. So you need to draw them first, and then you add carbons onto that. If the name says heptane, so it's 7, 3 ethyl. So on the third carbon, you need to have an ethyl group. And for triple bond, it is linear. So those 4 carbon needs to be horizontal, and then you add octane, another 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8. For cyclohexane, it is actually similar, and then you just see the name hexane 6, 1, 2, 3, 4, 5, 6, and then you draw them in a cyclic shape. Cis and trans isomers. Okay, so the same, you look at the name pentene, so it's 5, 1, 2, 3, 4, 5, and you draw the double bond first, remember, so it's 2, so on the second carbon it will be the double bond, and then you draw this carbon, and then those 2 carbon, and then it will be trans to pentene, similar to this one. 1, 2, 3, 4, 5. On the same side, draw a double bond first, and then add those 3 carbons.